Okay, so one thing that we want to, get a little bit more practice working with trig functions with is proving identities. These are semi-useful considering you've already been using one identity a lot, the Pythagorean identity, and this is a way for us to find other identities that could maybe help us in the future. Proving identity is different than solving an equation. We're not trying to find out what x equals. We are trying to get this side to look like this side. And we can work with both sides. We're usually going to start off with one side, but we can work with both sides. But because we're not trying to get them to be equal, we're not trying to solve for anything. We're not going to want to move things across the equal sign. We don't want to clear fractions by multiplying both sides. We want to work individually with each side and just rewrite it the same way that we were when we were just combining these trig functions. So I'm just going to start, I guess with my left side, and say I can rewrite that, and I can say it's cosine, because secant is just 1 over cosine of x, and sine would just be sine of x. So I could write this as cos of x, sine over cos of x. Okay, well now I have a fraction over a fraction, so I can flip and multiply. So cos of x times cos of x over sine of x. I lost my x up there. So this really gives me cos squared x over sine of x. Okay, so again, hopefully I remember my Pythagorean identities. Pythagorean identities were the sine squared, and I'll write it right here just so we have it, sine squared plus cos squared equals 1. This is true for any angle I put in. Sine squared plus cos squared equals 1. So if I solve this for cos squared, I would move over my sine squared, and I would get cos squared to be 1 minus sine squared. So I could sub that in for cos squared. Still over sine of x. Now I have a common denominator. Usually when we're combining fractions, we're trying to find a common denominator. Here I already have one. So I'm going to go ahead and just write it as two different fractions with that same denominator. I'm going to split up the fractions instead of combining them. And the reason I'm doing that is I see this minus up here. So I know I want two different terms. So I'm going to get 1 over sine x minus sine squared over sine x, sine squared x. Now if I look at this, if I simplify 1 over sine x, that gives me cosecant. If I simplify sine squared x over sine x, that gives me sine x. So I did it. I proved the identity. I got this to look exactly like my right side. And I did it just working with one side, but again, we're going to do a few where we work with both sides.